All right, so we're going to start, first of all, by briefly reviewing domain and range. This is something that's increasingly important the more complex our functions get, okay? So I want to start by taking a look at a couple and also review, if we're dealing with different types of notation, okay? So here we have three kind of similar graphs, and I want to talk about how we would, or just demonstrate how we would come up with the domain and the range for each of those. First of all, domain is what? What x can equal, all right? Or what your independent variable, you could say, would equal. And then your range is what your y, or the value of the function, your dependent variable, what that would equal, okay? Now notice here, one of the things you need to get used to is it's not necessarily always going to be x and y, and that's why I use those terms, independent variable and dependent variable. All right, here you can see we have x and w. Here's x and y, and here's x and z. Okay, and depending on different situations, we might use different letters. So it all means the same thing. It all works the same way. You just need to pay attention to the notation. Okay. Now, for each of these, there's two different kinds of notation that I want you guys to be familiar with that are used commonly. One is dealing with either inequalities or sets. We kind of go back and forth with that. And then also interval notation. The interval notation is the stuff that often people forget or maybe haven't seen before if they've come from somewhere else. So in this case here, I have 5 distinct points in my function, so I can't really write this as an inequality. Okay, why is it not drawing? Let's try this.
Is it blinking green?
No. It'll draw. Yeah.
Do you want to lock that? See if that helps.
I don't know what's going on here. Let's do this. All right, now let's try this. All right, I guess I'll just write it up here and we'll move it down. All right, so we can't write an inequality per se for this one, okay? We have to use set notation because inequalities you would use when there's a range of values. Here we would say that x is simply an element of a set, all right? And x obviously can equal 1, 2, 3, 4, or 5. So you would just list the values, okay? So x is an element of the set 1, 2, 3, 4, and 5. Okay, and that little thing that looks like an E is actually an epsilon, and that just means it's an element of. Now, our range also will have to put in as a set, and it's just the range, the value of w of x can only equal 3 different things. All right, so we could say w of x is an element of the set 1, 3, and 5. Okay? So we have there some set notation to identify our domain and range. Okay? Now, interval notation. Interval notation, like I said, is one of those ones that you may have forgotten, you may have not seen, or there are variations in this that we'll talk about. Okay, one. For one thing, interval notation again can only be used when you have ranges of values, not distinct values like this. So we actually can't write interval notation for this w of x. All right, it's just individual values. However, when we get to this second one here, we actually can, because these points are connected, we can come up with intervals. All right. Now let's start with the inequalities. We have x, and x goes from 1 to 5, and it equals 1 and it equals 5. So we would say x is between 1 and 5 inclusive. And then does anyone remember how we would write that as an interval?
Do you have any tomatoes? I'm about to start throwing them. Everyone who sat in my classroom should know how to do this, because we did this.
Come on. Intervals.
Okay, Rachel's hiding. Evan, I can see you. You know how to do this.
Wait, what's the question?
How do you write this as an interval?
Remember
What's an interval?
It's the box.
the front. Good.
Okay.
Yes, it's the box thing.
Yeah, the
From
box
and
thing.
Yeah.
Rachel.
You remember that?
From and to. Oh, I remember that.
You remember that?
Hallelujah.
Okay.
Eddie's piping up back here.
Okay.
Jason, I'm watching you. Zach, Elon, come on, you guys. Yeah, Lauren. Make the crowd.
All right.
Brian and Lauren.
Here we go. So we have an interval. Now, why did I put the box thing there? The brackets.
Oh.
It's okay. Hey, that was better than anyone else gave me, so. Why do we put that there? What does that mean?
That one is
All data.
included.
What?
That one is included, that there's a closed doc, so one is included.
Okay, it means that one is included because there's a closed point. All right? Let's say, for example, there was an open point on either end. So I didn't want to include 1 and 5. This is where some of you may have seen a little bit different stuff. Okay? What would I put instead of the brackets?
Parentheses.
Yeah, parentheses. Okay, I'd put this. All right? Has anyone seen anything different than that?
I've seen one of them is a closed point, one of them is an open point.
Okay, that is a possibility, yes. An alternative to the parentheses.
Oh, I remember this.
All right, it's coming back. Okay. Another thing you may see, especially if you're looking online or if you're working with some of your friends, sometimes I think in Brazil especially, it's taught this way. Okay. But they'll use the brackets, but they're turned backwards. Okay? So they have the brackets, but they're facing away. So that's another thing that you may see. It means the same thing as the parentheses. Alright? We'll use that again later here. Alright, so that's our domain, our range. Y or f of x. We'll just call it y in this case. It goes from 1 to 5 as well. And then the interval would actually look the same. It's the interval from 1 to 5 inclusive. Alright, so now we have this, and they've actually made it into this parabola with the arrows going on, so it goes on forever. So what can x equal here?
All real numbers.
Good. X is any real number. So you can write this a couple of different ways. You can have x and just have a negative infinity and a positive infinity. All right? But we don't like to write any more than we absolutely have to. So we would just say x is an element of the real numbers. Okay? X is an element of the real numbers. That just means x can be any real number. Now, as an interval, how would we write that?
Negative infinity to positive infinity.
Okay, negative infinity to positive infinity, and what do we use?
Parentheses.
Parentheses, yeah, because you can't equal infinity, right? You can only approach infinity. It's not a value that you can actually equal, so we use parentheses. All right, good. How about our range? Z of x.
Wouldn't it be greater than 0?
Greater than
Greater
greater
than
than
one.
equal to 1.
Greater than or equal to 1. Okay, good. Greater than or equal to 1. And then as an interval, how would I do that?
1 to
1 to
infinity.
infinity.
1 to infinity.
And bracket and parentheses.
Good. A bracket on this side and a parenthesis on this side. Good. Alright. So, any questions so far? Alright. So, now, let's take a look at one like this. Alright, this is actually the function f of x equals 1 over x minus 2. Okay? What would the domain be?
X cannot equal to.
Good. X cannot equal 2. And we can infer from that since we're saying explicitly that x cannot equal 2, that x can equal anything else. Alright? Now, you can also write this as a union, but you don't have to. Okay, you can just put it as x does not equal 2. What would the range be here?
X not equal to 0.
Y can.
Y not can equal. Y can equal 0.
Okay, good. Y or f of x cannot equal 0. And by the way, what do we call the line x equals 2 and the line y equals 0? Good, those are asymptotes. Those are asymptotes. Okay? Now, how would we write an interval when our domain is x does not equal 2?
X greater than 2.
Do you write 2 intervals? Yeah, do like 4. Oh yeah, that's right.
Okay, we're going to have to use 2 intervals with or a union between them. What are the 2 intervals going to be?
Negative infinity to 2.
Good, negative infinity up to 2. And am I going to use parentheses or brackets?
Parentheses. Bracket.
Parentheses, okay, on both sides, because we don't want it to equal 2. And then on the other side of this,
2 to infinity.
2 to infinity, okay? There we go. Now, take a moment and try to write the range as an interval. It's going to be a similar concept, but It looks very similar. What's the only difference here?
Replace 2 with 0.
Yeah, instead of it going up to 2, it's going up to 0. So we're going to have negative infinity to 0, and then from 0 to positive infinity. Okay? So that's all there is to it.
Does it matter which order of the values?
Like inside the parentheses here?
Yeah.
Yes, you always put the lower value first. And if we're dealing with 2 ranges, technically it wouldn't matter which order we put the 2 different intervals here, but just out of habit, we usually put the one that's lower to the left and then work our way up. Alright? Alright, let's try one last one here. This is a little different looking function. What kind of function is this? Do you remember?
Discontinuous.
Yeah, piecewise function. It's a function in 2 different pieces. Alright, here's a linear function, here's a linear function, but we're taking it in 2 separate pieces. Okay? So, for our domain, what's our domain here?
X is all real numbers.
Except for
Except for
Except for...
Oh wait.
Oh.
So X is less than or equal to -2,
Okay.
and then X is greater than -1.
Okay. Here we would need a union. You could write it as 2 separate things. Alright? So X is less than or equal to -2, or X is greater than -1. You can use this with, you know how we said X does not equal 2 in the previous one? It is possible to write this as one inequality, and we would say that X has to be, or cannot be, less than or equal to -1, and X cannot be greater than, -2. In other words, X cannot be between -2 and 1, and it can't equal -1 either. Alright? So you can do either way by either saying what it is or saying it's not between those 2 values. Okay? The only thing that's a little tricky with this is notice that it was a less than or equal to, now it's just a less than. It was a greater than, now it's greater than or equal to. Okay? So that changes, but if that makes sense, do it. If not, just use the union. Okay? Now for the interval, we have to use a union. Okay, so we would just use negative infinity up to -2 with a bracket, or parenthesis -1 to positive infinity. Okay, then what's our range?
Does it matter if you put -2 to negative thing or negative
Like, switch the order? Yes, it matters. You always put the smaller value first. Negative infinity is smaller than -2, so you'd always put it to the left.
Is it like if you're reading from left to right?
Yeah. Yeah, you wouldn't put, hey, I want the interval from 3 to 0, you know, going backwards. You would always put 0 to 3.
Oh.
Okay, always put it left to right, smallest to largest. Alright, so what's the range on this one?
Wait.
Real Oh, -3.
What?
-3.
-3.
Wait, yeah.
Good. It's greater than or equal to. All right. Here, f of x is greater than or equal to -3. Okay? So we would have bracket -3 to infinity. Okay? So that's not too hard, right?
Okay, so y equal 1.
Y can equal 1 because it equals 1 over on this part. Right here.
Ah.
Yeah. Any other questions? All right, the other quick topic I want to just touch on briefly, and then I want to give you guys time to work together on some stuff, is these piecewise functions, okay? These piecewise functions, I think the best way to think of it is when you're looking at the map, okay, you're looking at the map and you've got your GPS out or something and you see the highlighted route that you're supposed to take. But you see these other roads branching off, right? Okay, there are multiple roads that you can take, but from this point to this point you need to take this road, and from this point to this point you need to take this road, and so on. A piecewise function is very similar. All right, we have this line right here that is the line 2x plus 8. And we have this parabola right here that is the parabola x squared. Okay? However, what our piecewise function is telling us to do is, hey, until you get up to -2, follow the line. All right? So here is everything below -2. All right? Now we're at -2 and we stop. We're not going to follow the line anymore. Okay? It's saying once we pass -2, we need to turn onto this street. Okay? So to speak. We need to follow the x squared. So now we're going to go along this path. Alright? That's really all piecewise functions are. There's two different functions that are on the graph. For part of the domain, we want to follow one function, then we stop and we turn on to a different one for the rest of it. Okay? Same idea here. All right, we have x squared, which would be this function right here. Okay? And we have the square root of x, which actually does start here and goes on like that. But this piecewise function is saying follow the x squared until you get to 0, and before you hit 0, switch over to the square root of x. So square root of x happens to hit 0, 0 as well, and now we're going to follow it instead. Okay? So that's the idea with the piecewise function. If you're trying to find the equation or find the definition of a piecewise function, you need to identify what the two different pieces are, and then also identify what part of your domain or what part of your graph you want to follow each piece for. Okay? So to kind of revisit the one we just looked at, let's say we want to define this function f of x. Okay? First of all, we see the two different parts here. Part of it, it's going to be when x is less than or equal to -2. Okay, I'll put a little comma there because we're going to put the function in here. And then the rest of it is when x is greater than -1. Okay? And you guys remember, because we already stated the domain and range, what happens between -2 and -1? our function would be, it's outside of our domain, so our function would be, what? Undefined, okay? Our function is simply undefined in this range right here, okay? So, we need to identify what the equation of this line is. Can you tell by looking?
-2.
Okay, the slope's -2. What?
So y equals -2x.
-2x, and then where are we going to hit the y-axis?
Oh yeah, -7.
-7, okay? -2x minus 7. And then we have to find the equation of this piece.
X plus 2.
Good, x plus 2. The slope here is 1 because we keep going up 1 over 1, up 1 over 1, up 1 over 1. And then we're crossing the y-axis right there at 2, so it's x plus 2. Alright, so there's the definition of that function. We're going to follow this path from -2 down to -infinity. We're not going to be anywhere in this gap. And then we're going to jump onto this path and follow that once we get to the right of -1. Okay? So, we must have teleported there or something. Alright, any questions? Final questions? Good. Alright, so here's what I did. I gave you a number of different problems of various types. So what I want you to do is look through these, okay, work with somebody, and you know, here's one on finding slope-intercept form of a line that's parallel to another one, and a line that's perpendicular. You can't remember how to do that easily? Then do that one, okay? Work your way through. There's a number of different problems here, and a lot of different word problems, okay? So I want you to work with somebody. Here's some piecewise functions, all right? Finding the domain, find the values where the two functions are equal. These aren't all things that we just talked about. These are a lot of different things that you have had in the past, all right? So I want you to go through these and take a look, okay? And work through them, all right? Now, I did post these PDF in the notes online already, so you can bring up that PDF and you'll have all the problems since it kind of jumps around on multiple different pages. That'll keep it simple for you. All right, but go ahead and break up into groups now, get working on this, and I'll